Today we are going to continue with this next topic of today's session, sir. That is called the comparisons between electrical force and gravitational force. You have learned in gravitation, right? In your first year here, gravitation. So last chapter, almost at the end of the chapter, you have learned something called a gravitation. There you have learned one law. Hope all of you will be remember, right? Newton's law of gravitation. So Newton's law of gravitation is speaking about the masses. Here we are already learned about Coulomb's law. Coulomb's law is speaking about something called charge. Now we are going to do a comparisons between whatever you have learned in first year and whatever you are going to learn in second year also. Always when you are try to learn some equations also, some theorems also, some postulates also, always try to make some relationship between them. Always there are some connections are there, different formulas from first year to second year also, or within second year also. So connect it and learn instead of by hearting something. Always strongly I am recommending to understand the concept and then learn. So without wasting the times, we'll go move to the topic. So on your notebook, write down the heading: comparison between gravitational force and electrical force. Here to write gravitational force, I have used a letter symbol called Fg, and for electrical force I have used Fe. In your notebook, while you are writing, you have to write it explicitly: comparison between gravitational force in bracket Fg and electrical force Fe. This is just a short form I have used here. Okay, you can also use it but within a bracket after writing the sentence. So I'll make it as a tabular column, so easy for us to separate between these two. So left side column I am giving gravitational force, right side column I am giving electrical force. Okay, first listen to the board, do not write along with me. You can pause the video, then you can write it down. Okay, so the first point is gravitational force is attractive force. I am writing as always attractive. So gravitational force is always attractive nature. Why? Because it's related to mass. As like an example, this is a pen. If I dropping, it is always attracting towards the earth center. So gravitational force is always an attractive force. But what about electrical force? Electrical force means Coulomb's force. Coulomb's force is always attractive or always repulsive? It is both attractive and repulsive. We have learned in the last class, right? So this force is both attractive and repulsive. So this force is both attractive and repulsive forces. So first point is over. Second point, what is this equation for this gravitational force? F equal to G into m1 m2 divided by r square. What is the electrical force equations will be here? 1 by 4 pi epsilon 0 q1 q2 divided by r square. Magnitude format, not writing the vector format. While you see, while I am talking about electrical force, I told one parameter. This will be depends upon the charges q1 and q2 and inversely proportional to square of the distance between them. In additionally, one point I told epsilon 0. What is this epsilon 0 is called? Epsilon is called permittivity. Epsilon 0 is called permittivity of free space, which means free space, it's a medium. So this electrical force is medium dependent. Here any medium dependent quantities will be here. What is the value of G will be here? What is the value of G? 6.67 into 10 power of minus 11. What is the unit of this one? If you keep G will be here, you can multiply FGR square divided by m1 m2. Okay, so that is the, from there we will get the unit. So Fg, capital G equal to Fgr square by m1 m2. F in the unit, Fg in the unit is Newton meter square divided by kilogram square. Here similarly you know the value of 1 by 4 pi epsilon 0. Last class we have not written the value. You can note it down. 1 by 4 pi epsilon 0 equal to 9 into 10 power of 9. What is the unit of this one? Same thing. If I am keeping 1 by 4 pi epsilon 0 alone will be here, what will come? Newton. R square will come here, meter square divided by coulomb square. Okay, but the main point what I am going to highlight here is like Fg is not depends, Fg equal to, Fg is not depends upon medium. There is no epsilon 0 terms will be here, but this is depends on the medium, because epsilon 0 will come. Last class I told epsilon m epsilon m term I told, right? So this epsilon m and epsilon 0 in the previous topics we have learned, right? So that is depends upon the medium, and here it is medium independent. So gravitational force we can simply written not depend on medium. We are not dependent on medium. But what about electrical force? Yes, electrical force will be depends upon medium. Either it is epsilon 0 if it is in free space, normal air medium, and if it is in some other medium, like for example we are going to find out the attractive force between the two charges in a water medium, or repulsive force between the two charges in water medium. So medium will be changes, means Fe will be changes. So here it's not depends upon medium, here it is depends upon medium. So depends upon medium. Okay, so 2 points we have written. This is not depends upon medium, but that is depends upon medium. And the third point it says that gravitational force is always the weakest force in the nature, and comparable to gravitational force, electric force will be higher. So I can see Fg is a weakest force. Fe is a weakest force, but Fe is greater than Fg. Okay, so this is a comparison. Fg is a weakest force and Fe is not a weakest force. You can write on your notebook for your understandability. Fe is not a weakest force. Whatever is higher, if I am asking Fe or Fg will be higher, you will say Fe will be higher than that of Fg. So 3 points will be there. So Fg is a weakest force, but Fe is not a weakest force, it's a strong force. And the fourth point, the highlight of the fourth point is like the electrical force. Okay, what is the nature of like an electrical force? Electrical force is either an attractive force or an repulsive force. So it is like an action reaction pair. Okay, action and reaction pair. For example, I will write something here. For example, I have a charge called Q1. So what happened this one? I have another charge Q2. Suppose I am assuming both charges are positive. So Q1 will repel because of Q2 in this direction. If both are positive means not moving each other, right? One after another will move. So this will move like this. So this is moving like this one, and this is moving like this one. So both are moving in a different directions. Now if you see the force, the first force, if you see the first force will be here, the Q1 force. What will happen? Q1 is repelled by Q2. So Q1 is moving left side because of which charge? Because of Q2 charge. Okay, because of Q2 charge. And same way Q2 is moving right side because of Q1. So there is an action and reaction. Okay, if Q2 is giving an action to Q1, in what direction? Left side it is moving. Then Q1 will give a reactions to Q2 towards right side. That's what electrical force is, something called, it's an action reaction pair. So electrical force is always an action reaction pair, but no action reaction pair. No action reaction pair here. So 4 points I have discussed. Okay, you understand the meaning of action reaction pair. Action reaction pair, if I am helping somebody to move in one direction, for example towards right side to me, then that guy helped me to move in the opposite direction. So I am giving an action, he is giving a reaction. Here Q2 on Q1 is giving an action, Q1 will give Q2 on reaction. Newton's third law of motion, in first year you have learned, action and reactions are equal and opposite in nature. Why it is called opposite nature means it's in opposite direction. So this is applicable for Newton's third law of motion. Every action, this is an action, every action there is equal and opposite reactions are there. So every action there is equal and opposite reaction, that is truly applicable for Newton's Coulomb's law. But in case of gravitational force, there is no kind of action reaction pair if it is in a single body that is just attracted towards earth. But there are action reaction pairs are also there in a different context, but here it is always there. If I am keeping one mass in my hand, if I just drop it, it's just attracted towards the earth. So if I am keeping for example this mass on my hand, then it has two things. The body will apply an action on my hand and my hand will apply a reaction on the body. So when two surfaces are get in touch with the contact, then action reaction pairs are exist. So during the flow through the air, only action is coming to picture in a gravitational force, but here we can explicitly see an action reactions force are available in electrical force. Okay, so there are 4 points. I'll just repeat once again. Always it is an attractive force. Gravitational force is attractive force. Electrical force is both attractive and repulsive nature. Point number 1. Second point, Fg is equal to G m1 m2 by r square. You know the equation. Here 1 by 4 pi epsilon 0 q1 q2 by r square. Here because of epsilon 0 it is depends on the medium. Here it is not depends on the medium. Gravitational force is a weakest force and the electrical force is more stronger than gravitational force but not very high. Which is the very strongest force in the universe? That is called a nuclear force. Nuclear force means, you know, atom consists of the central core area is called a nucleus. Nucleus consists of neutrons and protons, that is called a nucleons. So the force exists within the nucleus is called a nuclear force. That nuclear force is the strongest force in the universe, and the weakest force is called a gravitational force, and electrical force is higher than gravitational force but lesser than nuclear force. So here Fe greater than Fg, and there is no action reaction pair kind of mechanism when a body is just attracting towards earth. But if two bodies will be there, two charges will be there, then there are action reactions pairs are exist in case of an electrical force. So there are 4 points will be here. Remember about the 4 concepts and the 4 points. Welcome to the next video of electrostatics chapters, the continuation, and that is called equilibrium of Coulomb's force, or we can say equilibrium of forces. So on your notebook write down the next topic heading equilibrium of Coulomb's force. Write down the heading along with me, equilibrium of Coulomb's force, equilibrium of Coulomb's force. What is called equilibrium? In physics, if you hear the word called equilibrium anywhere, any chapter, irrespective of the chapter, if you see the word called equilibrium, then the meaning of equilibrium is that body is in stable position or in rest position. It is not at all moving. So under the equilibrium of Coulomb's forces, 3 types of equilibrium situations. 3 types of equilibrium situations we have seen. Situation in the sense that these 3 types will ask us 3 different questions for Neet as well as for JEE examinations. Okay, so we'll go one by one. First, write down the subheadings. Equilibrium of the first subheading, I'll put it as A. Equilibrium of equilibrium of two charge particle system, equilibrium of two charge particle system. I'll tell you, I'll take an example, then I'll continue. Here also we have two subdivisions are there. Okay, there are two subdivisions are there. First we'll go with the first subdivision, number 1, A1, the first one. Two charges are like charges. Two charges are like charges. Okay, I'll tell you the concept, then we'll take one example and we'll see how it is working out. I have one charges, say I called Q1. I have another charge, say called Q2. You can see my heading, equilibrium of two charged particle system. So two charged particle Q1 and Q2, and these two charges are like charges, either both are positive or negative, anything it is fine. I am considering both are positive nature. Okay, now the questions will ask like, the question in a two charged particle system, the questions will ask like, where we have to place, write down along with me, where we have to place the third charge, Now there are two charges will be here. In order to make the systems to be in equilibrium state, I will place one charges will be here. So if I place one charges will be here, either I have three options to place, right? I have three options to place the charges. Either I can place it at the left side here, or I can place it in the middle somewhere here in between, or I can place it right side, where I will place a third charge, so that that third charge or the system, this third charge will come to an equilibrium position. Now we know we required a minimum two charges to have a Coulomb's force. Now I have a third charge. That third charge I can place it anywhere in between the system. We have three options, either to the left or to the middle or to the right, where I will keep the third charge, so that the whole system, not the whole system, that newly added charge, that placing charges either to the right, left or in the middle, will come into equilibrium. That is a idea we are going to analyze, it will be here. Okay, so I am going to place a third charges will be here, and we'll see what we will get it down. Okay, so let's continue. I'll rub these portions and I have to draw some diagrams over here. Okay, now I'm removing all this cross mark signs will be here. Suppose I'm assuming I'm placing my first charge will be here. Maybe this charge I'm giving as just a Q. It is a positive charges. Okay, I can place a positive or I can place a negative irrespective, but as of now I'm assuming all are positive charges. So this capital Q and with the Q1, because of the Q1, what will happen to this Q? Q will attract towards Q1, or will, this is also positive, so this will not attract, right? This will repel, so this will move like this one. So this is a force due to the first charge because of 1 on this charge, so I am giving F1. And Q is positive and Q2 is also positive. So this Q will attract towards Q2 or repel. It will repel, it will not attract, right? Because both are positive. So this will move like this one. So we will have another force called F2. We have learned superposition principle. If two forces are acting in the same direction, we will add or will subtract. We can simply add it. So if you are adding the total force on the system, F1 plus F2, so there will be a total force exist. Because of that total force, the Q charge will move towards left side. So what is the condition for the word meaning will be here? Equilibrium. What is the meaning of equilibrium? Equilibrium means total force equal to 0. No force should not happen, or if in case any forces are happened, both the forces are in opposite direction. If both the forces are in opposite directions, the magnitude of the two forces are equal which are acting in opposite direction, then it will cancel it out, that body will rest or it will not move, or no force should not happen. Okay, I'll tell you an example. Suppose this is a pen. If I am just pulling it in this side and pulling it in this side also, if both forces towards left and right will be same, this pen will move from my hand? No, it will not move, right? It will not move. So the forces can exist, but which are equal forces. If I am not at all applying any forces towards left or towards right, any sides, I am not applying any force, then what will happen? Then also this pen will be at rest position, it will not move. That's a simple concept. So here there are two forces are exist, both are acting in the same direction, so the total force exists, hence the charge Q cannot come to equilibrium position because there is a total force exist. So the placing of the charge in the left side is not possible. So this is a wrong assumption we have taken. We'll go to the right side. If I am placing the charge Q on the right side, so Q will be placed will be here. Now this is not possible, we understand this is not possible, and we are going to see whether that area is possible or not. If Q is also positive, the same Q, now you can forget about this part, we are only concentrating here. Q will be here, Q with the Q1, it will attract or repel, it will repel, so F1 force will be here. Q with the Q2, it will repel, F2 force will be here. It is similar to the same case will be there on the right side. Two forces are there, F1 and F2, both are acting towards right side. Total force equal to F1 plus F2, both will never cancel. We have some value, right? Because of that value, the Q will move towards right. So forces are not cancelling on that body, so because of that the body is not come to equilibrium state. So consideration of the forces at the right side is also a wrong aspect. So it should not be on right side, it should not be on left side. Now you know the answer. Of course it should be at the right side, but we need some logical explanations, right? Yes, we'll place it here at the charge Q will be here at the center position. What will happen? Because of Q1, Q will repel this force called F1. Because of Q2, Q will repel in this force called F2. So here there is a chances for an equilibrium. Why? Because two forces are in opposite direction. If these two forces are equal magnitude, for example this is 10 Newton, this is 10 Newton, then what will happen? Both forces will cancel each other. This charge will not move towards right, will not move towards left side. It is in equilibrium state is possible. So this is the only point I can say equilibrium is possible. So when this kind of question is come to you, like the question is related to equilibrium, I have so many times I have seen this kind of questions in the examinations papers. There are, of course, you know, like A, B, C, D, 4 options will be there. Two of the options, your options are matching. If you look into the options, your options are matching between the third charges should be placed between the other two charges, and the another two options will be there. Out of the 4 options, one option is given at the left side and one option will be given at the right side. These two you can roll out only if two charges are like charges. So understand the question scenario, based on that the filter the answer. So charges, if it is a like charges and the equilibrium condition, the only possible point is the charges should be at the not at the center. Do not write the word called center. I don't tell you it is always at the center. It may be any point, but only condition is in between the two charges, then it will come to an equilibrium states. Okay, we'll take one example question and we'll see how we are going to tackle these situations. Okay, so let's clean the board and we'll going to see. I'll keep the heading will be here. Now I told the concepts, right? In order to have an equilibrium state, the charge should be between the two charges. Let's take an example. Based on the example, I will try to solve. Suppose I have one charge called Q. Okay, and I have another charge called 9Q. Okay, one is a smaller charge, another one is a bigger charge. 9Q, it is Q. And the question is like the distance between the two charges is R meter. In the real question, this will be given some values like 4 meter, 5 meter, etc. But here I am giving R meter, for example. Then the question will ask, where should I have to place another charge called Q0? Q0 is another charge where I have to place left side, right side, or in between. Now you will tell, sir, both the charges are equal. This is 9, this is plus charges, this is plus charges. So definitely it should be somewhere here, Q0. In between the two charges. Now the question will ask, this is how far away from this one, X meter. Just I am giving X. The real entrance examination question for Neet and JEE, the question will ask, what is the distance value of this X? We need to find it out, right? First we'll going to write the equation for this one. Now if Q0 will be here, how many forces will act on Q0? Q0 will have two forces will be there, right? Because of Q. So one FQ force will act like this one, and this is positive, this is positive. So Q0 will also repel because of 9Q with a force called a 9Q. So both forces are equal, means the body is in equilibrium condition. So first we will find the value of FQ. FQ will be equal to, FQ means the Q0 is repelled because of Q. Tell me the equations. 1 by 4 pi epsilon 0 Q1 Q2, two charges. What are the two charges will be here? Q into Q0 divided by, what is the distance between them? X square. Okay, next, force due to 9Q charge. Force due to 9Q charge is like this one. So 1 by 4 pi epsilon 0 Q1 Q2. What are the Q1? Q1 is 1 is 9Q, another one is Q0 divided by, what is the distance between these two? Total distance is R meter. Here it is X gone. So what is this balance distance? R minus X. So we'll put it as R minus X the whole square. Now what is the conditions for equilibrium? To have a conditions for equilibrium, these two forces should be equal. Okay, we have to solve this one, and we'll see what the value we are getting for X. Okay, so we'll continue here. What value we are getting for X? If you are equating FQ equal to, I am writing FQ equal to F9 times of Q. So FQ equal to F9 times of Q. If you are equating these two, here 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, both will get cancelled, right? So Q0 will get cancelled. So what is coming on the left side will be here, just 1 by X square equal to, right side what is coming, this Q0, both sides will get cancelled. So 9 divided by R minus X the whole square. Both the side it is like a perfect square number, so I can take a square root on both sides. So what will come? Here it is 1 by X will be equal to 3 divided by R minus X. 3 divided by R minus X. So we have to solve this one. So R minus X will be equal to, I am writing like this one. So R minus X will be equal to, multiplying, cross multiplying, 3x. So R minus X will be equal to 3x. So how much, if I am taking x to the right side, 4x will be equal to R, and finally we got R equal to, how much will come? We don't want R, we need x. X will be equal to R divided by 4. So x will be equal to R divided by 4 is the right answer. This minus x taken to right side become 4x, 4x equal to R. So x is equal to R by. So the Q0 charge has to place R by 4 distance from Q. So how much distance from 9Q? 3R by 4. Okay, here one more important point we have to remember always. What is that important point is like, if you have two charges will be here, this is a lower magnitude, this is a higher magnitude. In that cases, if you are placing a charge and which is going to be in equilibrium state, then the position of the charge is always, you can see x is just R by 3. So what is the, if x is R by 3, what is R minus x distance? R minus R by 3. What is R minus R by 3? 2R by 3. Okay, so R minus, not R by 3, R by 4. So here it is R by 4. So what is R minus R by 4? R minus R by 4 equal to 3r by 4. Okay, so 3r by 4 is higher or r by 4 is higher? You know 3r by 4 is higher value, r by 4 is lesser value, which means q0 is always closer to the charge which has less value. Here it is higher value, here it is 9q, but here is only q. So when a charges the system, the charge which we have introduced into the system will come to equilibrium, so that the third charge has to place very closer to the lowest charge. So that's what the value x is equal to r by 4 is coming. Okay, this is the concept behind will be here, right? So the value of x. So there are something special things will be here. Here there is one kind of shortcut method will be there, which you can apply easily to find out the answers. Of course, you are very interested about the shortcuts, right? Why I am telling the shortcut means normally for entrance examinations we have hardly 1 to 2 minutes to write an exam, to tackle an answer and to find out an answer for a question, right? So here I come to x is equal to r by 4. This is the normal method which you can see any reference book, whatever you are referring, but understand the concept. Hope you understood. We find out the two forces, and two forces are in equal opposite directions, and if you are equating these two forces and we are find out in the value of x. So the conditions for body to be in equilibrium means either force will be equal to 0 or two forces which should act in opposite direction and has to cancel each other. Cancel each other means both are equal. So that's what we are doing will be here, and we are finding the value of x. How much distances the third charge has to place so that the system should be come to an equilibrium positions. Come to an equilibrium position. Then we'll continue. Next, as I told before, we have some shortcut methods. So a shortcut method is required to find out the value for this one. What is a shortcut method for this one? I'll tell you. Note down on your notebook. So if such kind of questions, remember two charges are like charges and it's a two charges system. So I'll keep this part will be here. I'll just rubbing the lower part, and answers alone I'm keeping it here. Okay, just for to check whether our shortcut methods will also give the correct answer for you. So we'll apply the shortcut method. The shortcut method means the value to find x. Always remember x, I have taken the distance from the lowest charge, not from the highest charge. Do not confuse. Okay, you will never end up with a confusion, sir. I'll always take it from the lowest charge. So x will be equal to root of q lowest divided by root of q highest plus root of q lowest. This is my formula. Now we'll apply will be here, right? What is a q lowest? Lowest charge in the form value is what? Root q divided by highest charge in the value 9q plus lowest charge in the value root q. Numerator root q. Here you can take one root q outside, right? If you are taking one root q outside, what will come? Root q divided by root q into root q to what is root 9 value? 3. Balance how much will be here? 1. This multiplied with the r, the total distance. I forgot to add here. Please add it. It is r. So now root q divided by root q into 3 plus 1 multiplied with r. R is the distance between the two charges, which should given in the question. Definitely that value will be there. So root q get cancels. So you got r by 4. This is what we got before also, right? We also got r by 4. This is the concept here. So this is a shortcut method. Please put it in a box while you are learning these things. You can quickly get an answer and becomes to do a smart answer for your entrance examination. So always try to remember this kind of formula, because a lot of time savings will be given in my couple of next series videos also. I will come up with certain formulas like this one, but always remember these things and highlight it in a box so quickly you can answer. But before you are going to answers, make sure I am applying the condition two charges are like charges. So what will happen if I am going with an unlike charges? Okay, we will see as a next topic.